okay? So we start. Now we go into, we have also done refraction through a glass slab, okay? We did Snell's law. Now we go into refraction through spherical lenses, okay? Now all of you must have seen many a times we use a magnifying glass to magnify something, to make it bigger, okay, that to make the image bigger so that we can read it easily. Then some of us use reading glasses also. I also use reading glass, okay. There it is. Can you give my reading glass, please? Okay, some of us use reading glasses also, okay. There it is, my reading glass. When I have to read something, I use it, okay. So have you ever felt the lens, okay? What is a lens? It should be, first of all, you get a question in example, or you have a question, what material should a lens be made up of? So the first thing which we learn is that a lens should be made up of a transparent material, okay, transparent. So if it is transparent, what do I mean by transparent? Can somebody quickly punch in, what do I mean by transparent, translucent, and opaque? Okay, quickly, don't take a lot of time, so that we can continue with the class, okay. In the meantime, I read further, okay. Material bound by two surfaces. If you look at my mirror, it has two surfaces, one towards me, mirror, I'm telling you. If you look at the lens of my spectacles, it has two surfaces, one towards me, the other away from it, okay. Two surfaces, of which one of them at least is spherical, okay. Good evening, Abiral. At least one of them is spherical. Nobody told me what is, light can pass through it. Very nice. Snigdha Siddhant say that light can pass through it, okay. Now when light falls on it, okay, you can see it is passing on. Okay. Some of it gets reflected. If I keep it like this, you can see some of it is getting reflected. This side also you can see some of it is getting reflected and the other is passing away. Could you see the light? Some light was reflected and other passed away, and it also absorbed some. Okay, I'll show it to you once again. Here, these are my spectacle lenses. I target, you can see one ray is coming this side, the other ray is going that side. You can see it, okay. Can you see it? Okay, so some light gets reflected and most of it gets refracted. It passes to the second medium, okay. Some gets absorbed. Now if it is transparent, it will let most of the light pass on, whereas on the other hand if it is translucent, it will let some light pass, okay. And on the other hand, if it is opaque, it absorbs most of it. It doesn't let light pass through it, okay. You get a shadow. Good evening, Abiram. Okay, so now you have understood that I should have a transparent medium to make a lens. And the second thing, they say that it should have at least one curved surface. It has got two surfaces, okay, and they say at least one should be curved. So if one is curved, then how does it look like? Okay, you see here I have a plain side, okay, and I have a side which is curved, which is bulging out, okay. A plain side and a side which is bulging out. On the other hand, I have again a plain side, okay, and the other surface which is curved, it is caving in, okay. So what do I call such a lens? I call such a lens a plano-convex. If it's bulging out, it's waxing out, it's convex. If it is caving in, it's concave. So this one is plano-concave. Okay, one surface is curved, so it becomes a lens. Had both been straight like this, then it would not be a lens. Okay, it would become a glass slab, which we have already done in the previous lecture, right? Now, how do I make out, if these lenses are given to me, how do I make out whether it is a concave or a convex? Now, a lens comes to me like this, I hold it, okay, and I move towards the edges. If the center part is thicker as compared to the edges, okay, if the center part is thicker as compared to the edges, it means it is a convex lens. Got it? If both the sides are spherical, then it is a biconvex. Okay, or I simply call it convex lens. Clear to everyone? If both the sides are vexing out, okay, then I call it a biconvex, or I simply call it a convex lens. And how do I make it out? By touching. I just touch it. If the belly is thicker than the edges, then it's a convex lens. On the other hand, I look at this lens. See, if I look at them like this, they look pretty similar, isn't it? But when I touch this one, I can see that the central part is thinner as compared to the edges. The edges are thicker. The edges are thicker and the central part is very thin. So this is a concave, biconcave, because both are caving in. I can simply call it a concave. Okay, I'll show you the edges now. Okay, you look at the edges. I hope all of you can see this one is very thin and this one is thick. Okay, so if two lenses are given and you look at the edges, if one of the edges is thicker and the other is thinner, then the second thing I feel is the central part. If the central part is caving in and the central part is bulging in, then I can very easily say that this one, the one with the thicker edges and the thinner center, is a concave lens, and one with a thicker center and thinner edges is known as a convex lens. Clear to everyone? Devil Gamer, good evening. Okay. So Devil, you got time for your physics class? Karan Srivastav, good evening. Okay, I continue now. Okay, let me erase this. Now if both surfaces are bound, if both surfaces are bound, both surfaces are spherical, okay, then I've told you, then this also becomes like this. So now this is a convex lens, and if both are caving in, then now it becomes a concave lens. Everybody, no issue in it? All of you have understood? All of you have understood how to identify? Give me a yes quickly. Okay. Now the next thing, if I am said that you cannot touch it, but you have to tell, okay, whether it is a concave lens or a convex lens. Okay, you can do anything with it, but you cannot touch the surface. Without touching the surface, you can tell. Okay, very nice. Snigdha Siddhant say they have understood. Sujal says yes sir. Tanishka says yes sir. Okay, so I go to the next thing. Now, if they say that no, you cannot touch the surfaces, you will soil the surfaces, आप उनको गंदा कर दोगे lenses को. Okay, so you cannot touch it, और आपको ऐसे ही बताना है, you can use some light if you want, आपको ऐसे ही बताना है कि ये concave है कि convex है. Okay, so I draw a line. Okay, I draw a line. I have a ray of light. It's a laser light. You can see it. It's going straight on the line. Now I put my lens. And what has happened to it? What has happened to it? Okay, when I remove the lens, it's like this. As soon as I put the lens, what happens to it? Punch in? No, I'll tell you. As soon as I put the lens, the light turns inwards like this. Which means if I have many rays coming like this, what happens as soon as they cross the lens, then all of them converge in, okay, at a point. So this is also known as a converging lens. Which one is known as a converging lens? A convex lens. A convex lens is also known as a converging lens because it converges a parallel beam of light to a point. Okay, we saw that. Now we do the same thing with a, we saw that it was converging. Now let's see what does a concave lens do. Okay, I erase this and I bring in my laser again. You can see it's on the line straight. Okay, and I bring, and what is happening? What happens to it? Okay, now you can see that this time it is going away like this. This time it is going away like this. The previous time it was coming towards the center, now it is going away. Got it? So what does it mean? It's a diverging lens. This one, because a parallel beam of light, if I have many such rays, okay, if I have many such rays, it sends them away. It sends them away. Got it? It sends them away like this. So the rays are diverging. Hence it is also known as a diverging lens. Okay? Very simple, all of you understood? So if they ask you, you are given a converging lens, which lens has been given to you? And second, first they say you have been given a converging lens, which lens has been given to you? Second, they say you have been given a diverging lens. Then which is the second one? First is this, second is this. Punch in quickly. Okay, till then I move on to the next topic. Let me clear all this. I'll be needing at this, I suppose. Okay. Very nice. One is convex, says Snigdha Siddhant, and two is concave. Absolutely right. A concave is a diverging lens and a convex is a converging lens. Very nice. Okay, Tanisha also says one is convex and two is concave. Correct, Tanisha. So just two people answered, Snigdha Siddhant and Tanisha, and both of them are right. Okay, now we go to some terms. You remember when we had done mirrors, then also we had done terms related to spherical mirrors. Now we do terms related to lenses. Okay, the terms related to lenses. Now, if I look at this lens, okay, if I look at this lens, it has got two curved surfaces, right? One is towards me, one is away from me. Now this curved surface, it's a part of a sphere, right? It's a part of a sphere. Had this been one piece, then it would have been a part of a solid sphere. When we were dealing with mirrors, I was telling you that it's a part of a hollow sphere. Now we have solid spheres, okay? A sphere made up of solid glass, and this mirror has been shaved off out of it, cut out of it. Okay, so this sphere had a center, right? We represent it with C. This sphere had a center. Okay, and if I go to the other part, similarly the other part also is a part of a sphere. I cut it off. Okay, had it been one sphere, it would have been a part of that sphere, and that also has a center. Okay, this is C1, this is C2. When we were talking about mirrors, we were having just one center, right? Now we have got two centers. Got it? We got C1 and C2. So these are known as, what are these known as? These are known as center of curvatures. There we had only center of curvature singular. Here we have center of curvatures of the lens. It has got two surfaces, so it has got two center of curvatures. Got it? The one here also we take that the light will come from the left. So the one on the left is C1, the other on the right is C2. And if I have an imaginary line joining these two centers, then this line is known as the principal axis. This line is known as the principal axis. Okay? Everybody understood? Everybody understood what are center of curvatures of a lens and what is the principal axis? If you have understood, give me yes. We represent center of curvatures by a C. Okay, one on the left is C1, one on the right we represent as C2 because we've got two center of curvatures. Okay, if both the surfaces are same, very nice, understood, very nice. Tanisha says understood, Snigdha Siddhant say understood. Karan Shrivastava says yes, understood, sir. Okay, now if the radiuses are the same, okay, if the radiuses are same, then it is called which means equal. It's called equiconvex lens, which means both the spheres have the same curvature. Got it? So it's equiconvex. Everybody understood? We move on now. Principal axis also done. We have told you. Now whenever now we go to refraction through a lens, okay? Whenever we go to refraction through a lens, we bring the light till the middle of it. Okay, we bring the light to the middle of it, and this line on which I have the center of the lens also. The center of the lens over here is known as optical center. Okay, optical center. If light falls on the optical center, it passes without deviating. Everybody understood? अगर लाइट ऑप्टिकल सेंटर पे गिरेगी तो लाइट स्ट्रेट ट्रैवल करती है, वो स्ट्रेट चली जाएगी, कन्वर्ज या डाइवर्ज नहीं होगी. ठीक है, इट विल नॉट बेंड. ओके, एंड the line which divides the lens into two equal parts having the optical center also on it, वहां से हम बेंड कराएंगे जब भी हमें कन्वर्ज कराना है. This is known as the principal section. Principal section. Okay, got it, everybody? Understood? Similarly, I'll have for a concave lens also. Okay, the concave lens, biconcave, this is the optical center and this is the principal section. The optical center is represented by O. The optical center is represented by O. This is O, right? So everybody understood principal center and everybody principal section, and everybody understood optical center. Now if I take a lens, let's erase this and we move forward. So I'm not writing them, I hope you are understanding. Till now we have discussed center of curvatures, we have discussed principal axis, we have discussed optical center, and we have discussed principal section. Okay, next what I do, this we have done in the mirrors also. I have this lens, I keep it on the sheet of paper and draw its outline. Okay, I draw its outline. Once I have drawn the outline, it looks like this. Got it? So the diameter is this one. So the diameter of the outline of the lens is known as what? Sir, please tell principal section again. Okay, Shikha, it's again bit a imaginary line. Okay, it's an imaginary line which is in the middle of the lens. Okay, it has the optical center also in it, and whenever I draw ray diagrams, I bring in the incident ray till there, and then I diverge it out. Okay, in case of a convex lens, I bring it till the principal section. Okay, and then I make it converge. Otherwise it happens at both the surfaces. Just for the ease of ray diagram, I draw a line in the middle which I call the principal section. Got it? And I bend my rays while making the ray diagrams once they touch this line. Very simple. Okay, it's not there in your books also. You will not be needing it much. Just to understand that when you make the ray diagram, make a line like this, and you should bend the incident ray only once it touches the line. Got it? Now you have to punch in this. I had told you, given you some time. I have drawn the outline of the lens. Okay, and I have marked its diameter. I can do the same thing for my concave lens also. Okay, I take the concave lens and I draw its outline. There the outline. Okay, and then I mark its diameter. So what is this called? What Shikha has understood very nice. What is this called? Punch in quickly. You should have punched till now. What is, we did this, the same activity when we are studying mirrors also. What is this called? I'll wait for a few seconds. Punch in if you can, punch in quickly. Who says? Very nice, Snigdha. Shlok Khare says center of curvature. No, Shlok, that is not the center of curvature. The effective diameter of the outline, the effective diameter of the outline, of a spherical lens is called its aperture. What is it called? It's called its aperture. Now Snigdha Siddhant had said, yeah, Mishti has says aperture, Tanisha has said aperture, Shikha Devan says aperture, and Snigdha Siddhant. So very nice, 5-6 kids gave the correct answer. We had done the same activity when we had studied mirror also. This is the portion through which light passes from the lens, okay? So the aperture tells you how much area, and in this class, in class 10, when we will study, we will take lenses only whose apertures are very small as compared to their radius of curvature. Got it? We'll study only lenses whose apertures, which means we'll be studying thin lens only. We will not study thick lens. That you'll study in class 12. Okay? Right? Everybody understood aperture? Now next we go. One more term, important term. Okay, I pick up a lens which has very thin edges and a fat center. Okay, and now I focus. Can you see something on the board? Can you see something on the board? Can you see something on the board? Yes, no. Can you see something? Tell me. Can you see something on the board? Why is it so hazy today? Just align it once. Okay. What did you see on the board? Did you see anything? Okay, I'll tell you. What did you see? Yes, you saw. What did you see? I'll tell you. I have got a tube light on that side of the wall. Okay, and you saw light, very nice. That was tube light slope, correct. Okay, you must have seen a light like this, isn't it? So I have a tube light on the wall next to me and I made its image. Okay, you saw me that I moved it a little like this till it was perfect. Okay, I kept on adjusting till it was almost perfect. Okay, which means I got a sharp image. Okay, so this position where I get a sharp image of the distant object, had I been in open space, had you been people along with me, I could have done it nicely in open space. When I was a small kid, I used to steal matchboxes. Okay, my mother used to hit me a lot. She used to shoo me away. She knew that I would take them away. What I used to do with them, I and my friends, we used to gather. Everybody used to bring match boxes from their house. Then we used to tie them up and we used to make a Ravan. Okay, a Ravan with the brown heads on top, the 10 brown heads on top. Then we used to make a small hole in the mud over there. We used to place it over there, and then we used to bring a lens like this. Otherwise it would have been very fast, one matchstick and gone. Okay, we used to bring out one of these lenses and we used to focus it. We used to focus the sun on the head of the matchstick Ravan, and after some time Ravan would ignite and would start burning, and all of us would dance around it and celebrate. Okay, so what we used to actually do is we used to focus the image of the sun on the head of that matchstick Ravan. Okay, you have got an activity. What is the activity number? 10.3. 10.10. Okay, The activity is 10.10. I'm not having the NCERT book. There it is. Let me check the activity number. 10.11. Activity is 10.11, wherein they do the same activity, but instead of my Ravan, now they have a paper sheet. So what they do is that they take a paper sheet and they focus the image of sun on this sheet of paper. Okay, and once it is focused, then they keep it for some time. And what happens? They say, don't look at the sun; it may harm your retina. Okay, and once I focus it, then the paper starts burning. It becomes brown. Some fumes start coming, and it may catch fire also sometimes. Okay, during the summers. So what have we done? We have focused. So this position, okay, this position, now I have a convex lens. Light is coming from the sun, so it will be a parallel beam of light. Okay, once it hits the lens, then it passes through a point. Then all the rays pass through a point. Got it? And what is this point called? Huh? Why is it so today? Okay, maybe it's because of my poor connectivity. Okay, so all of them, they converge at a point, and this point is known as the focus. This point is known as the focus of the convex lens. The distance between its optical center, okay, which means this distance, and the focus is known as its focal length. We represent the focus by a capital F, that we had understood when we dealt with the very nice. Pratyush Pandey says focus, Snigdha Siddhant says focus, Tanisha says focus, and the Vanshika says focus. Very nice, Vanshika. Okay. Now it has got two spherical surfaces, which means if I make the light come from that side, the rule is that light should always go from the left. Okay, I say suppose I bring in the light from that side, it's a equiconvex, then I'll get a similar point this side also. Okay, which means I've got two focuses. Got it? Or what I can say, if I have a lens like this, and on the principal axis I have a point through which when light goes to the lens, then it becomes parallel. Okay, so this also is one of the focuses. When I bring it from that side, then it converges here, and when I place a luminous object over here, one emitting light, then after refraction all of them become parallel. Got it? So it has got two focuses. So one on the left is named as F1 and one on the right is named as F2. So a lens has two principal foci. Very nice. Snigdha, the only thing, better don't name it small f1. Small f makes it focal length. Got it? We are talking about the focus. So it should be a capital F1 and a capital F2. You are right otherwise, okay? But there's a slight distinction between them. Everybody understood this? Okay. We have understood. Now we go to concave lens. So we have understood the focus of the two focuses, the two foci of a convex lens. Now we go to a concave lens. The concave has thicker edges and a thinner middle. A thicker edges and a thinner middle. A line connecting C1 and C2 is the principal axis. Okay, this is the principal section, and here I have the optical center. Okay, now when a parallel beam of light strikes a concave lens, then what happens? Aryan Shaw, what's it? Okay, now as soon as a parallel beam of light strikes the principal section, what happens? It goes away. Okay, it goes away. What kind of a lens this is also called? What kind of a lens this is also called? Okay, so to me they appear to be coming from a point like over here. Okay, again here also it appears to be that it is coming from a point. Here also it appears to me that it is coming from this point, and here also it appears to me that it is coming from this point. Here it passes undeviated. Focus is in front of the mirror. Diverging lens. Very nice. Pratyush Pandey, Tanisha, Avirala. I had asked you what kind of a lens do we call it? We call it a diverging lens. You can see that the rays are diverging. They are going away from each other, diverging. So it's a diverging lens. Will they ever meet? No, they will never meet. So what do? You must have seen, I have made a dotted line. Okay, I have made a dotted line. What does the dotted line suggest? The dotted line suggests Karan Srivastav. Yeah, they'll never meet. It's a diverging lens. No, they'll never meet. Very nice. Aviral, Pushpendra, and Aryan. Okay, so I extend them backwards. And if I look from this side, then to me, it will appear that the rays are coming from a point. Got it? Which to me, it will appear that the rays are coming from a point on the principal axis. Okay, while defining a focus, you always have to write a point on the principal axis. It appears to come from the focus, say Snigdha and Siddhant. Very nice. So out of convex and concave, which one has a real focus and which one has a virtual focus? Out of the convex and concave lens, which one has a real focus and which one has a virtual focus? Which one has a real focus and which one has a virtual focus? Quickly. No? I hope you remember real and virtual. Okay, if the rays actually meet, yeah, there comes Pratyush Pandey says concave has a virtual focus. Aryan Shaw says concave has real. No, Aryan, you're wrong. Okay, Snigdha Siddhant say concave has virtual and they're right. Pratyush Pandey says convex has real and he is right. Okay, so I told you if the rays actually meet after refraction, agar rays intersect करेंगी तो I can place my screen over there and I can get the image. जैसे हमने sun की image अभी ली थी, isn't it? हमने ये notebook ली और ये sun को focus करा और हमने sun की image हमें screen पे मिल रही है, मतलब वो converge होके actually वहाँ पे मिल रही हैं. So if the rays actually meet after refraction, then that's a real image. So I am getting a focus where the rays are actually meeting in case of a convex lens. So it's a real focus. In case of a concave lens, this one, they are not meeting, they are diverging away. So I imagine them, I place my eye over here and I imagine them to be coming from a point. So if they are coming from a point, then it's not actually coming, I'm imagining them to be coming from a point. So imaginary focus, which means a virtual focus. Everybody understood this? Okay, so we have done terms related to spherical lenses. We have understood what is the center of curvatures, what are the center of curvatures. Okay, we have understood the curved surfaces. Okay, two surfaces bound by two spherical surfaces, then only it's a lens. At least one should be there, that we have understood. Then we have understood a line, imaginary line which joins the two center of curvatures is the principal axis. Then we have understood that the center of the lens through which light passes undeviated is known as the optical center. Then we have also understood, okay, that when a parallel beam comes, it converges at a point. In case of a convex lens, that point is called as the focus. Now it has got two surfaces, so they'll have two focuses. Left one wala is capital F1, right wala is capital F2. So we've got two focuses. And the distance from the optical center to the focus is the focal length. Got it? Okay, now you have understood this. You already know the Cartesian signs of mirrors. Now in the time when I'm talking, you have to tell me. तो अगर मैं फोकस लूंगा, दो फोकसेस हैं, मैं एक एक फोकस लूंगा, जब भी पैरेलल जब भी मुझे कोई करना है तो मैं पैरेलल बीम लेफ्ट साइड से मारूंगा और जहां पे फोकस बनेगा दैट आई टेक एज द प्रिंसिपल फोकस फॉर ऑल माय कैलकुलेशंस फॉर न्यूमेरिकल्स. ओके, तो नाउ इन द मीन टाइम दैट आई एम टॉकिंग यू हैव टू टेल मी कि कनकेव और कन्वेक्स में से किसका फोकल लेंथ पॉजिटिव होगा और किसका फोकल लेंथ नेगेटिव होगा. यू कैन जस्ट थिंक. सो डू वी हैव अ फिजिक्स टेस्ट टुडे? Monday you are having, I suppose. You don't have a physics test today. They're going to give you a quiz, a very simple quiz wherein you'll get 15 question, multiple choice questions. Not today, I'm not very sure about it. I'll just inquire once the class is over and I'll let you know, okay? Anything anybody wants to ask? I've given you a question. किसकी focal length positive है और किसकी focal length negative है? It's given in the schedule, then it must be there. They had a talk with me in the morning and they said something they are rescheduling. I'll just confirm after the class, okay? Right now. Okay, the answers have started coming. Pratyush Pandey says concave will have a negative focal length and convex will have positive focal length. Very nice. So just one child answered and he is correct. Okay, I measure all distances from the optical center. If the distance is towards the direction of light, I take it a positive. If it is against the direction of light, I take it as negative. So in this case, it is towards the left. So इसका जो focal length होगा वो negative होगा. Concave lens की focal length negative होगी. और अगर मैं convex लेता हूँ तो convex में parallel beam converge होके यहाँ पे मिलेगी. Okay, this is the optical center towards the left. Okay, towards the right. I'm so sorry. Towards the right. तो राइट पे हम पॉजिटिव लेते हैं तो इसकी फोकल लेंथ पॉजिटिव होगी. राइट, I'll not start the new topic because I'm left with just 4-5 minutes. So I'll continue with this. I'll just give you a brief of activity 10.12 जिसमें कि अब हम रे डायग्राम्स बनाएंगे और हम पढ़ना शुरू करेंगे. I can tell you about the basic rays. Okay, 4 मिनट में 4 बेसिक रेज तो बता ही सकता हूँ. So let me do that. Everybody has understood this much? Okay, so now we have understood terms related to lenses. Now we go to construction of ray diagrams. क्योंकि next जो topic है हमारा वो different positions, object की different positions के लिए image की different positions, image का nature, image का size हमें समझना है. Okay, so I'll just tell you the basic rays today. Next class when I start, I'll repeat these 4 rays. So I'll do these quickly today. So you'll get a feel of this, and next class when I start, I'll repeat the rays and then go into the ray diagrams. Okay, so the first one, okay, I have to take just 2 rays. मैं कोई भी 2 rays लूँगा जैसे हमने मिरर में बनाया था वैसे ही. Very nice, Vanshika. We are into the last part, beta. This class will finish in 4 minutes. Just pay attention. Okay, so हम कोई भी 2 rays लेंगे ray diagram बनाने के लिए. पहला रूल ये कहता है कि this is the principal axis, this is the optical center. Okay, पहला रूल ये कहता है कि अगर मेरी रे प्रिंसिपल एक्सिस के पैरेलल आती है, अगर मेरी रे प्रिंसिपल एक्सिस के पैरेलल आती है तो वो रिफ्रैक्ट होने के बाद F2 से जाएगी. अगर मेरी रे इन केस ऑफ अ कन्वेक्स लेंस प्रिंसिपल एक्सिस के पैरेलल आती है तो रिफ्रैक्ट होने के बाद वो F2 से जाएगी. एवरीबडी अंडरस्टूड? इन केस ऑफ अ कनकेव, ये इस बार आया था, CBSE ने ये वाला पूछा था इस बार एग्जाम में, तो इसको ध्यान से देखना. ओके, नाउ दिस इज द ऑप्टिकल सेंटर, दिस इज द प्रिंसिपल एक्सिस. अब इस केस में क्या होगा, अगर मेरी रे प्रिंसिपल एक्सिस के पैरेलल आएगी तो ऐसा लगेगा जैसे वो F1 से निकलती हुई आ रही है. Alright? If a ray parallel to the principal axis strikes a concave lens, then it appears to diverge from F1 or the principal focus. तो इस केस में हम प्रिंसिपल फोकस राइट हैंड साइड ले रहे हैं, उस केस में हम प्रिंसिपल फोकस लेफ्ट हैंड साइड ले रहे हैं. कनकेव के केस में F1 को हम प्रिंसिपल फोकस लेंगे फॉर ऑल कैलकुलेशंस, फॉर ऑल न्यूमेरिकल्स, और इस केस में हम F2 को लेंगे. राइट, The second rule. Rule number 2. I've already told you the rule number 2. पहले rule number 3 बता दे. Rule number 3 is easier because I want to do it quickly. Okay, rule number 3 says कि अगर मेरी रे ऑप्टिकल सेंटर पे पड़ेगी तो वो बिना डिविएट हुए निकल जाएगी. A ray incident on the optical center passes undeviated. Okay, same here also. A ray incident on the optical center passes undeviated. I took this early because my time is almost up. I want you to think, आखिर ऐसा क्यों हो रहा है कि अगर रे यहाँ पे टकराएगी तो डाइवर्ज हो जाएगी, लेकिन यहाँ O पे जा रही है तो सीधी निकल जाएगी. अगर रे यहाँ पे टकराएगी तो कन्वर्ज हो जाएगी, ठीक है, लेकिन जब ऑप्टिकल सेंटर में जा रही है तो अनडिविएटेड पास हो जा रही है. क्यों पास हो जा रही है? यू हैव टू थिंक अबाउट इट एंड यू हैव टू आंसर मी. ओके, दिस इज योर क्वेश्चन which you have to ponder upon, think, okay, research and give me the answer in my next class. So next class when I come, I'll ask you straight away that I had asked you to explain why, give logical reasoning why a ray incident at the optical center in both the cases, whether it is concave or convex, passes undeviated. Give a logic to it. We'll start from here. Thank you very much. I hope all of you learned, all of you enjoyed. Thank you very much. See you.